Hi, Jackson.
Hi, say hi. Hello. Hi.
How are you tonight?
Good.
Okay. So let's try to work on some of your homework tonight so that we can prepare you a little bit for this test coming up. We can't spend all of our time on that other stuff, although you need to be spending some of your time on that on your own.
Yeah.
Okay. Not sure what I'm looking at here. I can't quite read 1A. I can read it starting with 1B. Hold on, maybe I can read 1A. Find and can you read the rest of it?
Use the graph to show the height y and feet of a tree x years from when it was planted. Find and interpret the slope of the graph.
All right. So if I said to you, the time that a tree has been planted was 32 years, how high is it?
Well, I don't know.
Okay, when you're looking at a graph, the three most important things are the title, the horizontal axis, and the vertical axis. What's the horizontal axis in this case?
Height.
Nope. Horizontal is where your eyes go left to right.
Oh, then that's time.
Okay, that's the horizontal axis. The vertical axis is height. That's where your eyes look up and down.
Yeah.
So when I tell you that this tree has been alive for 32 years, which axis are you going to look on first?
The horizontal.
Okay, go to 32. Now look up and down at where the graph crosses. Now look all the way to the left and read the height off the left.
Wait, what do you want me to do? Sorry.
I want you to figure out how high the tree is after 32 years.
Uh, wouldn't it be about 38? You're saying?
Well, here's what we're looking at. We're looking at 32 right there, right? Can you see where I'm drawing?
Yeah.
Okay. Now we go up to where the graph crosses.
Yeah.
Now we go over to read what the height is.
Yeah.
What's the height?
The height is 50.
Okay, that's the answer. When the tree has been alive for 32 years, its height's going to be 50. Now, they do give you some points on here. I made that up. In other words, I was looking for a nice round number, but they do give you this point here. What does that say? That when the tree has been around for what? How high is it?
Here's 22 years.
And it's how high?
36 feet.
Okay. And how tall was the tree when it was planted?
3 feet.
You got it. Okay, so what were some of the other questions they're asking in that first question? Find the slope? All right,
Right.
how are we going to find the slope? Slope is what? Tell me what slope is.
Slope is rise over run.
Perfect. Exact answer I was looking for. Slope is rise over run. Well, what's the rise?
The rise is the height.
No, the rise, I'm going to write it like this. You may have never seen it like this before, but nonetheless, I'm going to write it like that because I think that's the way to understand it the best.
Yeah.
Delta y means the change in the y coordinate. Delta x means the change in the x coordinate. Well, I have 2 points. I have this point here, and I have this point here. So tell me what the change in the y coordinate is.
33.
Perfect. In other words, it's 36 minus 3. And tell me what the change in the x coordinate is.
Okay, 22.
Yeah. So what I have is 33 over 22. I can divide top and bottom by 11. I get 3 halves. Now, if we add units, the change in the y is feet. The change in the x is years. So what does that tell us about this tree?
Wait, can you repeat that? Sorry.
Yeah, in other words, we figured out the slope, okay? And the slope was the rise, which is in feet.
Yeah.
And the run is in years.
Yeah.
So we get an answer of 3 halves feet per year.
Yeah.
That's exactly what that means, is this tree grows how fast? How fast is this tree growing?
It grows 3 feet.
No, 3 halves of a foot per year.
It goes 3 halves of a foot.
3 halves is 1.5, so it's 1.5 feet per year. And you can figure out that it does that for the life. It's a straight line. It doesn't ever curve like that. So the fact that it's a straight line means it's going to grow, whatever its slope is, it's going to grow that much. If you look at 36 years, well, we're saying it's going to grow 3.5 feet per year, or excuse me, 1.5 foot per year. So that's 36 plus 18 should be 54. It started at 3 feet tall. It should be 57 feet tall at the end of 36 years. Well, let's check. Bingo, 57, right on.
Yeah.
Okay. So now they want to know the equation of this thing. What's the general equation of a straight line? We can see that it's a straight line. What is it?
Well, I know x or y is undefined, so.
Y equal mx plus b.
Yeah.
That's what you want to remember for the next 5 years. That is a very important general formula. Now, for this particular straight line, we got to fill in m and b. Well, what's m?
M is 3.5.
What's b?
B is 5. No, not 5. I mean 3.
Perfect. B is the y-intercept, which means that number right there, which is 3. And that is the slope. And you have to make sure that you get the sign on the slope right also. That is a positive slope. Let me give you some slopes and you tell me whether they're positive or negative.
Alright. Negative. Negative. Positive.
Horizontal line.
Alright. Undefined.
0. The horizontal line is 0. It's the vertical line that's undefined. And in case you're wondering, undefined means infinitely steep.
Yeah.
In other words, if I draw some slopes, that's a slope of 1. That's a slope of 3. That's a slope of maybe 10. That's a slope of 1,000. Notice what's going on. The steeper our positive slope, the bigger it is. And so by the time you reach a vertical line, it's at infinity. Whereas if I go this way, that's 1/2.
Yeah.
That's 1/4. Where am I headed towards? I'm headed towards 0. Horizontal line is a slope of 0. All right. I'm not sure, but I think we answered everything here. You came up with the right equation, y = 3/2 x plus 3. And then they said, so what's the height after 30 years? You plug in 30 for x and you solve.
Yeah.
I'd like to see you do this math slightly differently. You have 3/2 times 30, okay?
Yeah.
Now, the way you did it was you multiplied numerators, and you did it like that, and then you simplified that to 45. Right?
Yeah.
Ah, you made a mistake. Ah, plus 3. Excuse me. So you got 48. You got the right answer. Still, when you are doing that process right there, I would like to see you do it keeping your numbers as small as possible. And one thing I can do is divide top and bottom by 2. So I can get rid of that 2 and turn that into 15. And now I multiply 3 times 15 to get 45.
Yeah.
And I don't have to go through that step there. Notice that I don't ever deal with a number bigger than 45. I don't deal with 90. And when you can keep your numbers smaller, your accuracy is going to be much bigger. So get in the habit of doing this kind of step where you simplify those things when you're multiplying. If I'm multiplying 3/2 times 100, I'm not going to do 300 divided by 2. I'm going to cross that out and make that 50. And now I'm going to do 3 times 50, which is 150. I kept all my numbers as small as possible.
Yeah.
All right, let's see what else we got here. Interpret the y-intercept of the graph. Correctly answered. The tree was 3 feet tall when it was planted. Okay, number 2, you are draining a water tank. Well, first of all, let me ask you, all of these answers that are on here, these are your answers?
No, we corrected it.
What's that?
We corrected it.
Okay. So we do need to go through each problem, in other words?
Yeah.
Okay, let's do 2. You're draining a water tank. After 4 minutes, there are 10 gallons of water in the tank. After 6 minutes, the tank is empty. Okay.
Yeah.
At what rate is the water draining from the aquarium? So let's examine what they said. They said after 4 minutes, there is 10 gallons in the tank. After 6 minutes, there is 0 gallons in the tank. So tell me what happened.
Oh, well,
How fast did it drain?
every 4 minutes,
Oh, start with this. In other words, how many gallons left the tank?
10,
Okay, so 10 gallons over what time frame?
4 minutes,
No, the difference between 4 and 6.
2 minutes.
2 minutes. So that rate is 5 gallons per minute.
Yeah.
Now, notice what we did. We didn't have a graph, but we took the difference in the y's, the difference between 10 gallons and 0 gallons, and we took the difference in the x coordinate, which was between 6 minutes and 4 minutes, and that's how we got 10 gallons per 2 minutes.
Yeah.
Which turns into 5 gallons per minute. And that's a key number. That's the slope. That is well, they don't tell you that it's linear, but we're assuming it's linear drainage, meaning that it's going to drain at that same rate, no matter how full the tank is or how many minutes have gone by. So, at what rate is the water draining from the tank? We have figured that out. You got it. 5. Oh, I like the fact you put the correct sign on it. -5. I didn't do that. When something is draining, it's going to have a negative sign. If it's increasing, if you had a hose in the tank and you had added 10 gallons over a 2-minute period, then the rate of change would be positive 5 gallons per minute. But the fact that it's emptying is what makes it negative. And
Yeah.
mathematically, it's negative also, because you're going from 10 to 0 as you're going from 4 to 6. So the most important thing about slope, in other words, slope does not just rise over run is what you'll remember 10 years from now. And I like to say that's delta y over delta x. But the one they ask you to remember is y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. And that's what they've done right here.
Yeah.
And so the order that you do it is important in determining the sign. If I happen to switch these up, if I do y sub 1 minus y sub 2, I'm going to get the wrong sign on my slope. In other words, to get the proper sign on your slope, you have to make sure that these are done in the same order. Always do y sub 2 minus y sub 1. You could do y sub 1 minus y sub 2, but then you'd have to do x sub 1 minus x sub 2 also.
Yeah.
It would give you the same number. Okay? So, how much water was in the tank before you started draining the aquarium? Well, let's look at this a couple of ways. I can see how they've told you to do it. Make a table. Let's do it a different way. This is a linear drainage. It is constant with time. That means if we were to graph it, it would be a straight line.
Yeah.
Its slope is negative, correct?
Let me see here. Yeah. Mm-hmm.
So our vertical axis is going to be volume in gallons.
Yeah.
Our horizontal axis is going to be time in minutes.
Mm-hmm.
Okay? We
Yeah.
know that at 4 minutes, we've got 10 gallons. Correct?
Yes.
And we know that at 6 minutes, we've got 0 gallons. Correct?
Yeah.
We connect those 2 points with a straight line. This is what we started with. That's 0 minutes. Okay?
Wouldn't it be 10 over 6? Say you multiply 6 and 10, and then you get 60 and you divide that by 2.
I tell you what, let's write as much of this equation as we know. I right off the bat don't know where that's going to start. So let's write it. Y equal mx plus b for starters. We're trying to solve for b, right?
Yeah.
We know what m is. What is m?
M is 30.
-5.
Oh yeah, no.
In other words, we calculated that slope. Remember, it was 10 minus 0 divided by 4 minus 6. So m is -5x plus b. So there is the equation of that line. And what we have to do is figure out what b is. B will be, that's how full the tank was when it started. Well, we know a couple of points on this line. What's this point right here?
That's 40.
It's 4 comma 10.
Oh yeah.
In other words, the time is 4 minutes. The tank has 10 gallons in it as its volume.
Yeah.
So if that point is on the equation of that line, it has to fit that equation. Okay? That is the equation of that line. Therefore, every single point on that line has to fit this equation. Well, that point's on that line. So let's fill it in. 10y equals -5 times x, which is 4, plus b. Well, -5 times 4 is -20. So now we have 10 equals -20 plus b. Solve that. What's b equal to?
Oh, B is equal to wait, can you repeat? Sorry, I kind of cut the mic cut out.
Okay, look at that equation right there that I just circled. And solve it for b. That's the whole reason I need you to be able to do arithmetic.
Equals 2.
No. All right, let's talk about solving equations.
Yeah.
I'm erasing everything on this page but this. Upper left. How do you solve an equation? I'm trying to solve for b. I want to get rid of everything that is with that b. In other words, I want my final step to be b equals something.
Yeah.
It doesn't matter if the b is on the left or the right. The key is I got to isolate it. Well, I got a plus sign in front of it now. Let's just leave it on the right. So I got to get rid of that -20. What is that -20 currently doing?
It's currently
Being added to b.
Oh, okay.
So what do you have to do?
You have to
Always have to do the opposite. What's the opposite of being added?
subtract.
Okay. So I've got to subtract a negative 20. Or I could look at it as adding 20. Okay? An easier way to look at it is I'm going to add 20 to the right side. Which means I've got to add 20 to the left side.
Yeah.
Now what do you get?
Now you get 30.
Equals B.
Yeah.
Now, in the context of our problem, does that make sense?
Yes.
Yes, it does. We would expect this water tank to be fuller. If it's losing 5 gallons per minute, then it must have been fuller than 10 gallons at the beginning. So it passes what I call my ballpark test, which is make sure this answer is not less than 10. If you got an answer of 6, you know you've made a mistake.
Yeah.
Because there's no way it could have had 6 gallons, drained, and then had 10 gallons after 4 minutes, and then have empty after 6 minutes. That would be impossible. So that's one way to do it. There is a couple of other ways to do it, and they're probably easier, but let's just review them because it's important that you be able to look at these problems from multiple angles. Okay? I know that I'm losing 5 gallons per minute, right? And I have 10 gallons in the tank after 4 minutes. So work backwards. How many gallons have I lost in the first 4 minutes? If I'm losing 5 gallons per minute,
20.
20, exactly. So I must have had 20 more gallons.
Yeah.
So I can do it really quick without doing it like algebra, but it's the same concept. Okay?
Yeah.
All right. Let's see if there's any. That's about it. That's probably a good place to stop. Are we going to pick up on this document tomorrow? This is your document for your test on Thursday?
Yeah.
Okay. Well, we'll pick up where we left off, which is after 2. I guess we'll start with number 3 tomorrow. I will talk to you tomorrow at 3:30, Jackson.
Bye.
All right. Bye-bye.